Hello, everyone, and welcome to Exchange.js on this sometimes wonderful, sometimes stormy June evening. Thank you all for joining us. We have a series of wonderful talks. There's no slide for it, so I will just say that I am Ian Philipchuk. I work at a company called Punchcard, and I will be your host for the evening. Unfortunately, you won't be able to get rid of me for at least another hour or so. So hopefully you don't mind the sound of my voice. So like I said, welcome to Exchange.js. A quick agenda for you. We're going to go over our code of conduct, which we do at the beginning of every one of our Dev Edmonton talks. Go over some business items, go over a quick little bit of news associated with JavaScript. We have a bit of Node news, a bit of anti-Node news, and some Angular news as well. And then we'll have two wonderful talks done by members of the community. So by attending one of these talks, you agree to our code of conduct. This is hitting a little bit closer to home, given the events that are happening right now. So we decided that we weren't going to make a statement on it, the events that are unfolding in the States currently and across the world, given that we are kind of a meetup group and we haven't had a chance to really draft something. We will say that the code of conduct strictly prohibits any and all harassment based on ethnicity, culture, sexual orientation, anything. There's no harassment to be tolerated here at all. That being said, if you do want to do something, this link that you can see right there is a fantastic place to start. It's what I would emphasize if you wanted to contribute, if you wanted to become educated, if you wanted kind of any of those things, this is a great place to start. That being said, we do support all people in their strive to become humans. So that's kind of all we'll have to say about that. And as always, our code of conduct can be summed up as being kind, be patient, and be awesome. Like Bill and Ted said, always be excellent to each other. If you want to talk, ordinarily when we were in person, we would have everybody walking around with name tags. It would have these little yellow buttons. Unfortunately, since not everyone can be on screen at the same time, these yellow buttons don't really work. So if you're new here, I would encourage you to reach out, which is over that way. The directions are all messed up for me. And that's my actual email address. I will respond if you email me if you want to talk about anything related to JavaScript. If you wanted to maybe present in the future, I'd be happy to answer any and all questions. And of course, we always have a Slack that you can go to get any of your questions answered. Normally, you notice this slide says you might be on YouTube, but spoilers, you are on YouTube. So if you are putting comments, remember that those comments last for all time. And Mark can pop comments up on screen at any point in time. So if you don't want to be publicly called out for perhaps not having some snacks on hand, then yeah, fantastic. Exactly like that, Mark. It's like we've rehearsed this. That just remember that the internet is forever. So in terms of our news, I'll keep this kind of short and sweet. Angular 10, there's some news coming out about it, about all the new features. So if you are doing JavaScript of kind of a Google variety, that's going to be of interest to you. And Deno 1.0 is kind of emerging as a potential challenger to Node.js, which is a really interesting thing because it's like a titan of the space. And if it can be knocked off even slightly, that's a huge market share that might happen. And it wouldn't be a talk from someone from Punchcard or hosted by someone from Punchcard if we didn't mention TypeScript in some way. So TypeScript 3.9 is soon to be hitting or has currently hit, and it's going to be really making TypeScript that much faster, which I've heard is a common complaint. And of course, as I mentioned before, we have the Slack for Exchange.js. It is part of the Dev Edmonton Society Slack where you can communicate with a whole bunch of people. You'll be rubbing elbows with people who do Python, who do .NET, who do mobile development. And it's a wonderful place to network, to share experiences, to look for new opportunities. It's just a fantastic place. And I'm in it, so it has to be great. Our next meetup is on July 2nd, 2020. It is the day before my birthday. I will be excused if you'll be fine if you don't get me a birthday present. It's fine. And as always, we are always looking for speakers. I would emphasize that even if you are a first-time kind of viewer of JavaScript, or if you are a new graduate or you're a current student, there is no experience required to be a speaker. I am absolutely willing as well to talk someone through a talk. I've given a number of talks at Exchange.js, and we're here to support you. So if you have an interesting idea, or you want to show off a project, or you want to spark some discussion, please get in touch. That, again, is my actual email. I will respond to you. Or you can always go to exchangejs.com/talks, and that will link you to a Google document where you can put your ideas in. Talks have been kind of in flux at the moment, so we're always looking for people. Now is the perfect time. You have a captive YouTube audience, so it's a great way to get your name out there. So yeah, reach out, obviously, if you want to do a talk, and it could be about anything. We had a number of presentations, not even on JavaScript in the past, so anything kind of browser, web, or JavaScript related, we'll try and find you a spot. So our first talk is by Richard Mills, who is a new graduate who is working at a local startup. And oh no, I have closed my email. I will let him introduce where he is working, and he is going to be talking to us about Nuxt.js, which is, as I understand it, a framework for Vue.js. And now you can see him below me, the magic of the internet.
Hello.
I will say, if you have questions at all during the presentation, to put them into YouTube comment section. Ian and Mark, me and Mark, will be grabbing them, and then we'll be presenting them afterwards. If you have questions that come up during the question period, please feel free to share those as well. So I have talked too much. It's time for the feature attraction. So Richard, when we slip over to your slides here, why don't you take it away?
Sounds good. I have to do the old awkward figure out how to share my screen again thing. Okay, so I assume that everyone can see my screen here. I am presenting on just one computer with one screen, so I get to just look at my slides, so I have no clue what's happening outside of my presentation. But anyway, I'm Richard Mills, and I want to present to you a tool that I like. So this is an introduction to Nuxt.js. And I have here a meta framework, or a framework for your frameworks, if you will. First, who am I? I'm Richard Mills, as already been mentioned. I'm a recent graduate of McEwen University Computer Science. I'm a junior software developer at a startup called Quote to Me here in town. I just started there in January. And on day-to-day basis, I develop in Vue and Python. And in the Vue development, I use Nuxt, which we will get into here right away. First, I guess, who is this talk for? Maybe you use Vue and you would like a tool to generate a production-ready project. This is good for you. Maybe you just like Vue and you want some more structure to your project. So I know there's a lot of best practices. In this talk, I'm going to talk about the structure of a project quite a bit in a bunch of different aspects, because it's one of the things that Nuxt does really well. So go along with that. Maybe you just want a structured project in general. Maybe you're interested in Vue and you're just sort of curious what is out there. Maybe you're interested in front-end frameworks just in general. I mean, there's enough of them, so why not just dive into another one? And I just want to say, so this talk is not about Vue, but Nuxt is built on top of Vue and for Vue. So if you want to use Nuxt, you're probably going to want to use Vue. Otherwise, you're mashing things together. All right, what does Nuxt do? So Nuxt allows you to easily start a Vue project from scratch. So this will include like Vuex, the store, Vue router, and Vue meta. It can allow you to build your project as with server-side rendering, as a single-page application, or a statically generated site. It provides functionality based on project structure, and I'll get into that more in the back half of this. It is also modular, There are official plugins, community plugins, or just homebrew your own plugin and plug it into Nuxt. It's easy enough to do. And then it's enjoyable. So one of the things Nuxt really focuses on is developer experience. And I really like this. I really enjoy it. And that's why I'm here pitching it to you guys. So why I like Nuxt. I like Vue. I really like, it's probably my favorite right now for just building UIs. It allows you to easily create a Vue project. So if you've ever spun one up from start, plugging in all the libraries and modules and all the add-ons can quickly become a huge headache to get it all working together. The project structure has meaning, something I find really interesting. And these two are sort of tied together, but writing routes is just a pet peeve of mine for whatever reason. So Nuxt will build routes for you, which is super nice. There's a ton of modules available, official and community, and it's easy to configure, which I'll also touch on sort of in the back half of this. Just as an introduction, it felt wrong to not talk about what it's like to start a Nuxt project. So once you have the command line tool, it's a really simple wizard that just steps you through everything. So like, first you're gonna choose your server-side framework. You have 8 choices to choose from. Then you're gonna choose your UI framework. This time you're presented with 10 choices or none, always a good option. Then your testing framework. So now you just Java or just an Ava or your own, so none. I find it funny that the only module that the wizard presents you with is Axios, so popular. And then you can choose to add ESLint or Prettier. And these frameworks that it supports out of the box is sort of why it's considered a meta framework. So like you'll use it to set up your project. But then besides like plugins and the occasional configuration, you're gonna start working in all these other frameworks that you've imported with Nuxt. All right, so I talked about plugins. So what are those? So Nuxt is extensible. There's a handful of officially supported plugins. So HTTP, content, Axios, the only one presented during the wizard. PWA for easily making progressive web apps, and auth for the authentication service. Honestly, here I only have familiarity with Axios as far as the official plugins go, but there are many, many more unofficial plugins. When I linked over to GitHub, I was hit with 168 repositories that matched this query. I had a quick look through those. There's a tons. I've only used a handful, like Sentry, but like if it's out there and it's popular, it's almost certainly been configured for working with Nuxt, so you don't have to do it yourself. All right, so I kind of hope that you have an idea of what Nuxt is, which is like a framework to help you set up a project and incorporate all those frameworks that are ultimately going to be your final product. And it'll help you like configure them, put them together, build, all that fun stuff. But most of the time, you're probably going to be working in these other frameworks because that's what you're actually going to have the users use. But I do want to get into just some of the cool things that Nuxt does. Okay, so I mentioned writing routes is just something I don't enjoy. I find it really repetitive. So here I just have a common pattern for writing a route with Vue. Even if you're not familiar with Vue, you can probably understand what's happening here. So we give it a path. We have the component. In this case, the first one is a parent, so that's going to be the layout. I have like a little common pattern here with the meta tag for telling it to do something else with it. Routes doesn't care about this. Typically, you care about it. And then we have the children, which will actually have our index route. So all of this set up for one route with a layout. Setting up additional routes is less work, but it's still pretty repetitive and not interesting. So here we have my terrible, terrible Google Slides drawing of a directory. So the pages folder is something that is built into Nuxt. So when you start, like when you spin up your project, it's going to be there. And it's going to allow you to not write the routes yourself. So I tried putting like a directory structure here on the left, right? And then what that URL would look like on the right. So first one, index.js, boom, there we go. I realize I'm looking at this now, and I didn't notice it before, that these should actually be Vue files, but you can probably use your imagination for this. Then I also have the things folder, so that's just arbitrary. Inside we can have an index.js or Vue. Now we have our things route, so whatever that component is going to get loaded. For those wondering about how do you fit parameters into a directory structure, sorry. For those wondering about how you put parameters into a directory structure, this is how they do it. You have the underscore, so we have the parameter ID. So now we'll have an ID within our route. So things.id at index, or we could have new, and we'll have things ID new. And then these components can access that parameter, and then you'll have them in Vue. So this is one of my favorite things about Nuxt. I really don't enjoy writing routes. But then there's the issue of middleware and layouts. So with the other pattern of writing routes, you can sort of if you have a parent, that's how you'll apply your layout, and your middleware you can plug in a variety of different ways that I'm not going to get into here. That's more Vue-centric. But in Nuxt, we have two more folders we're given. One is middleware, which we can put in just JavaScript files, and one is layouts, where we will put in Vue files. So here I have a little snippet of just say a page component. So we have access to two more attributes. One is middleware, which we can put in arrays, so we can have a bunch of them. We can have a whole middleware pipeline. And the other is layout. Because the project structure includes these, there's no importing. Just the string we use has to match everything before the extension. So super simple. You got your layouts, you got your middleware, you've got your routes. All you need to do is stick to the directory structure and plug in a few keywords or attribute names. So mentioned it was easily configurable. So this is done in a very common JavaScript fashion. You have whatever the framework is, .config.net or .js. So you have a configuration file for doing all your things. This is where you will load your plugins, configure your modules. You can set environment variables that are set during build time, which then you can access everywhere in the code. For those who have used build frameworks, this is pretty typical, but very nice. And then ultimately, it's a JavaScript file, so you can execute whatever you want. This file has a ton of attributes. For those who are really interested in it, I would recommend going to Nuxt. I don't want to get into it here. It's a little more in the weeds than I want to get for an introduction. But yeah, that's basically the gist of it. All right. So I mentioned homebrewed plugins or just plugins in general. So this is another nice thing that Nuxt exposes. So when you set up your plugins in their folder and you give them a name and you load them in the config, all you have to do is supply this function definition or fingerprint. And what it will do is allow you to easily inject whatever you want to into Vue. So I have my little contrived example here of my plugin. Those who are familiar with Vue, the result of this is like if you were trying to do a similar thing, is to set it on the prototype so that you have access to this always in your components. For those less familiar with Vue, in a component, you would now be able to access this plugin at this $$ my plugin. So super easy, super to configure. Your context comes with lots of nice things like the app instance, the Axios instance, the store, so you don't have to worry about importing any of that. You just get to roll with it. All right. So just a quick summary here. So Nuxt is a Vue framework. It's meant for Vue. It's built on top of Vue. It's modular and extensible. There is a lot of community modules available. There's the official ones, and you can easily put your plugin ones in that will be run during build. It supports a number of frameworks. I believe from the setup, we counted at least 18 or 20. Hence why some people call it a meta framework or a framework for your frameworks. It allows you to easily start from scratch, just roll with the wizard and you'll have a project going in no time. The project structure has meaning, which personally I think is the most interesting. So automatic rote creation via the pages folder, easy layouts via that folder and including them in your page components. And the same for middleware, which allows you to easily set up a middleware pipeline. Yeah, and then you extend it, community, official, homebrewed, whatever you want. It's great. There's a lot more in this that I have not personally used. I wanted to do this talk mainly because I saw that it hasn't been talked about before. I really enjoy the meaning that the project structure has. And it's just a great tool to roll and build with. So I guess, are there any questions? And if I could stop sharing my screen would also be great. Okay, so we have a question up here of comparisons between Next.js versus Nuxt.js. Unfortunately, I have not used Next.js. As far as the main frameworks go, I don't have a ton of experience with many of them. The only other one I've spent a lot of time in is Quasar, but that's sort of like, it shares a lot of similarities as far as running a project go, except that the meaning of the directory is implicit rather than explicit. And it's not as like Quasar is sort of its own package and you don't get the other framework. So sorry I couldn't answer your question directly as is, but I haven't done a ton of front end. Besides dabbling, most of it has now been at work at Code2Me. Yes. Do we have other questions? All right, question. Would you recommend starting with Nuxt for someone who wants to try out Vue? Yeah, I think it's like Nuxt will do the project setup for you. So you can do this a lot too with like the Vue CLI tool. And maybe if you just want to write pure Vue and maybe with a simple server to serve it with, then sure, just start with Vue. But if you want to like, maybe you want to try out Vue with some UI frameworks, I would definitely recommend Nuxt then. But maybe just to appreciate what it does. If you just want to dabble with Vue, you don't care about UI framework tool to start it up. Do we got another question? Oh, there we go. What's the advantage of a Nuxt plugin over just including a library in your bundle? That's a good question. They do a lot of the setup and configuration for you. So I sort of showed that template of the like that inject function. So with something really common that doesn't tie into a lot of things, you could probably get away with just installing the library and writing your own plugin to load it in. This is all assuming you want to inject it into Vue or do some setup during build. So mainly the modules like that Nuxt makes available or that the community makes available is just, it ties better into Nuxt. So that setup is done for you, so you don't have to worry about it. And then you can also configure it in the like a Nuxt config file. So typically like if you're using Axios, you can put Axios in there and you can configure it that way. Or if you're using like Sentry, even though it's a community one, you can configure it all within this file without sort of like doing it yourself. So it allows you to centralize your configuration and not worry about injecting. All right, when you deploy this app, you can't serve it as the same origin as your API, can you? I believe you can. I don't see why you couldn't. Sorry. Just think for a second how to answer this one. So like in a production environment, we serve from the same origin, but we split the requests via a server, but that's because we have a separate backend. You could also write your API and have that like a node server. I don't know if that answers your question or not. I believe I had this question, but would you recommend starting with Nuxt for someone who just wants to try out Vue? If you want to roll with the UI frameworks that Nuxt supports, and you don't care to learn about writing routes the manual way, totally. If you really want to learn Vue, I would spin up first with Vue CLI. And then I would graduate to one of the more comprehensive build frameworks. Everything, all right, so I'll read the question. Vue's own docs are super good in my opinion. Does Nuxt have great docs as well, or are there recommended sources for getting started with it? Everything I've wanted to do with Nuxt, I've been able to use their docs to do it. Having said that, I have had like great mentors to work with as well, and I'm sure that helps a lot. And I also have really great code to reference, which is oftentimes even better than docs. But everything I've had to do, I've just gone to their docs or the module docs, depending on what I'm looking at, and it's all been fine. They're not as comprehensive as Vue's docs, because Vue's docs are great. But like, you sort of set up Nuxt and roll with it. Like when you get right into the weeds of configuration, then you're looking for docs. And I feel like you probably won't encounter that too often. It's pretty easy to run. All right, do we have more questions?
Hello,
Hello.
I am back. Fantastic job, Richard. That's kind of the end of the questions that we have for you. Is there anything else you want to say before we banish you to the corners of the internet?
All right, before you get rid of me, just thanks for listening to my talk or watching my talk or whatever the right terminology is. It was my first one, hopefully not last. And yeah, thanks. Thanks for having me.
Awesome. Well, we look forward to seeing you all around Exchange.js, hopefully in the future. Hopefully you're not a one and done kind of person. So.
Thanks.
Cool. Well, so that was Richard Mills' talk. Next up, we're just going to take a quick 2-second pause here so that we can isolate the talk completely. Excellent. I think that was about 2 seconds. Next up, we have Abram Hindle, who will be talking about WebAssembly and impractical WebAssembly, which I cannot wait to see what that means. So we'll take a 2-second talk again, a 2-second pause again, so that we can isolate it, and then we will get to Abram, and I will mute myself.
All right. Well, thank you for that introduction. I'm here to talk to you about WebAssembly, impractical WebAssembly, WebAssembly the way you're probably not going to use it. So WebAssembly is pretty interesting because people are trying to make high-performance JavaScript, especially on numeric code in the past, and they're coming up in different hokey ways of doing really kind of tight JavaScript with no abstractions. And eventually they started coming together, come up with WebAssembly. And WebAssembly is basically a binary instruction format that uses a stack-based virtual machine. And it's important that it's a virtual machine because people were very worried about the security of your browser as assembler was run within it. So as WebAssembly.org says, WASM is designed as a portable target for compilation of high-level languages like C, C++, Rust, enabling deployment on the web and server applications. Okay, so this means they actually don't care about you writing it, and they don't care about you reading it. In fact, the documentation for WebAssembly is not for beginners. It's quite poor, and I think that you basically need to be publishing at PLDI, the Programming Languages Conference, in order to make a lot of sense of the WebAssembly documentation. There are some introductory things out there, but they're far and few. Now, during this talk, because it is assembly, a lot of you are probably not super familiar with it, or you know a certain kind of assembler and you're trying to connect it to WebAssembler and you're just trying to figure out that connection. Please feel free to ask questions during this talk. I'm totally open to questions. I really would prefer to answer questions than to give this talk itself. All right, so what am I covering today? I am covering how to write WebAssembly by hand, how to compile it, and the basics of WebAssembly. What I'm not going to cover is I'm not going to cover how people actually use WebAssembly. Most people compile C or Rust or Go to WebAssembly. I don't care about that. If you like to use TypeScript, you'll use something like AssemblyScript, such that you can do WebAssembly in a TypeScript compatible kind of typed fashion. I'm not really going to get into the nitty-gritties of WASM bytecode. I'm not going to talk about what's called WAT without S expressions. And I'm not going to talk about ASM.js, and I'm definitely not going to talk about mscripting. Those are the things that you'll actually use if you want to use WebAssembly. We're going to talk about WebAssembly itself and how you can write it by hand. But before we start, you have to be aware of why it was made the way it was. People are really concerned that if you had full assembler on the web, that you would be able to do things on a machine and get very low-level access. This means row hammer attacks where you're reading memory via statistical inference. They're very concerned about safety. So security is at the forefront of WebAssembler, and it takes a big performance hit because of it. But essentially, you don't want to run other people's code like that willy-nilly, so maybe it should be safe. Also, they want it to be portable. It should run in almost every browser, and currently it mostly does. Furthermore, they cared about performance, but they cared that it was fast enough. Current implementations of WebAssembly are frankly good enough or fast enough. They were also really concerned about loading. JavaScript payloads have been getting really big, and people have been using different techniques to reduce that. So what they wanted was a concise binary format that's easy to compress, that's easy to ship, that's very small, not big like, say, x86 64 or something like that. They want a nice, compact representation, and WASM actually achieves that. All right, so before we start, let's just recognize there are certain limitations. WASM made the choice of security over performance. They also made an issue where you can't actually write assembler in the browser. You have to use a compiler or assembler to take your program and convert it into WASM, the binary format, and then you can load that. It's also very difficult to share information between JavaScript proper and WASM. There's also a lack of expected features if you're a programming language designer and you're kind of expecting to compile down to WASM. This means a lack of go-tos, a lack of a visible stack. They use these kind of weird type pointers that you have no access to and you can't manipulate, as well as typically the way you're going to interact with it in JavaScript is through typed arrays into basically this linear memory that they allocate. I'm just going to flip down. All right, so feel free to ask questions at any time. They'll mostly get read out to me or I'll check them out, and whatever, just ask questions. But I do recommend that you go to my GitHub and you go and get the code yourself and give it a shot. If you go to Abram Hindle, github.io/impractical-wasm, you get these slides, and these slides can evaluate WebAssembly for you because I jammed in the WebAssembly compiler. Normally what you got to do is to take this WebAssembly code, which might look like Lisp to you, but trust me, it's not. is to run wat to wasm on that file and make a main.wasm out of main.wat. Okay, so this is a text format, wat, and what it produces is a binary format. Then in JavaScript, what you typically do is you go and you fetch your wat, you load it up, you jam it into a WebAssembly object, you get its exports, and then you run it. And it does pretty well this. So in this case, it's returning 42. Let's just walk through this program very quickly. First off, we start with a module. Now I define a function. It can be any function. I'm just using main for this presentation just because it's easy to know what I should be running after I evaluate. And then I say, I want main exported such that we can actually call main down here in the JavaScript. I'm going to say that this function returns an i32, so it's a 32-bit integer. And what I do is I call return, and I give it a 32-bit constant. So it returns 42, which is a very special number. All right, so let's boot up. Our module holds our assembly. JavaScript also, that's basically what JavaScript imports. And we can export to JavaScript, but we can also import information from it. So if you want console.log, you can actually make an imports and have it imported into WASM such that it can call it. So that's kind of fun. Now, I'm going to use the S expression format because I love Lisp and I love S expressions and I think that they're great. They're a nice way to show that you have a tree of computation. So the way to read them is that this S expression between these two parentheses is going to be evaluated. It's going to have this as the thing that gets evaluated, and this is its parameter. So this gets evaluated, and then it returns like a constant 42. And then this one gets evaluated, and it's going to return that constant. So it's basically like a tree of your program. You don't have to write it this way, but I'm not going to write it the other way. The other way is to not really use S expression structure and take advantage of the fact that WASM is a stack machine. This is really annoying. So what we do is we push a constant onto the stack, and then we push an opcode onto the stack, and there's nothing really left on the stack. So what it does is it says, okay, the first available opcode I see is a return. So it runs that return, and then that return pops that 42, and then the return does its business, which is returning a value. So it popped the 42, and now it pushes the 42 onto the stack, such that anyone who wanted the output of main will now get this integer 42. Fun. This gets more complicated when you have opcodes that have more than one parameter. So yeah, we're going to stick with the S expressions because they make sense, whereas these are a lot harder to use. You do get better control of your WASM if you use this kind of format, but you're writing WASM by hand. You need all the help you can get. So we'll just stick here.
Abram, we have a question.
Yes, great.
So the question came up from Stephen Myers in the chat that this doesn't really look like what you'd expect from traditional assembly.
Right. It's mostly because it's assembler for it's not traditional assembly because it's assembler for a virtual machine, a stack-based virtual machine that has hidden memory from you that you can't access. So it gets really strange. And it even provides you a lot of abstractions that typically you'd have to do yourself in traditional assembler. For instance, the function, no one ever provides you with this one. Sometimes the CPUs have a little bit of help for you. They've got a return where they deal with the function call frame on the call stack, and they can return from your function with a value and all this kind of stuff. WASM does it for you. So they do provide some abstractions, but it's such that they can have a really tight, small virtual machine that can run it pretty fast. So I hope that answers your question. It is definitely a very high-level assembler. All right. So we're just going to get into it real fast. So we're going to quick boot. So to export a function, you have to call export at some time. You can really jam these right immediately after you define them. So here I use a $sign to indicate a symbol, mainly main, and then I say export it as the string main. Okay, this string will actually show up in the compiled assembler. And then I say it has a result, and then I have the code. If you don't export the function, your JavaScript won't see it. All right, let me just check real quick. Advent code. Right. Okay. All right, next up, the function. How do we make a function? Well, we have the FUNC opcode, and the FUNC opcode is not really an opcode, it's a definition. It allows us to define a function, and it will set up all the data parts for us that we need. We give it a $ symbol name. We can export it immediately after. We don't have to. If we don't export it, JavaScript won't see it, but maybe we don't want JavaScript to see it. For every parameter, you go param, and you give it a name like $x and then a type. You always need a type. This is what's really interesting. WASM is type checked and fully typed. If I use F64, a 64-bit float, instead of I32, and I try to jam that in there, it won't compile. It'll complain because it's statically type checked it, which is pretty cool. We also have the return value. So this is kind of backwards compared to how you normally write Java or something, or C, but it works mostly good. And then after this, you have all your little S expressions, which will be the function body. Okay? So that's a function. And so here I've got a demo of basically defining a function and calling it. So functions are great, but they're only great if we can actually use them. So in this case, I'm making a function I'm not exporting. It's called func with arg. It has one parameter, x, and all it does is it just returns x. Okay, so in order to access
another question.
X, great.
So that function returns an int32, but JavaScript can't represent 32-bit ints. How does that work? Does it get converted to a double?
A double can represent a 32-bit int pretty well.
What happens?
So,
What
but
happens if there's a type mismatch?
Oh, when there's a type mismatch, your WAT compiler will complain bitterly, and it won't make a WASM file for you. So you'll see the error, and you'll have to debug it. So it will type check for you. Yeah. But back to the first one. Yeah. So, okay, I forget the first one. What was the first one?
The first one was about 32-bit integers converting to doubles.
Oh, usually that's not a huge deal. Doubles have about like 48 bits of mantissa, so they can hold a whole 32-bit int. There is problems with it because you have nans and things like that, and you also have negative zeros and all that confusion. That is a problem. But the other way of dealing with it is to use typed arrays. So if you're really concerned about type coercion, use typed arrays. Okay, I think I got it. I'll continue on with this example. In this example, I have two functions defined. I'll just evaluate it. And what I do is I've got getLocal here, so it just returns this value. Notice how this function returns something without a return. That's another cool aspect of WASM, and from a Lisp user like myself, I really enjoy the fact that expressions, the final expression is returned. Essentially what happens is if there's any values on the stack after the function returns, it returns that value that's left on the stack. So when we run main, what main does is it has to call the function. We can't just go $func with arg, so we have to use the opcode call. And what call will do is it will look for the definition of func with arg, and then it will call it with the parameters, and that will all be on its own private stack that you don't see. So the call stack and the stack that has these values, like getLocal, you don't see, but it's going to mess with it, and it's going to call func, and it's going to have the parameter, and you can go get that local. So in order to call a function, you need to do this. I tried getting this value, and I think this is like a function type, and I can't resolve it into like an integer value. So I don't have access to this. If you need integer access or functions accessed by integers, you can make a func table, which I'm not going to talk about in this talk, but it allows you to be very dynamic with your functions if you need that. So it is available, but it's fully typed, which is interesting. All right.
We have another question about variable types in this case. You can't write a program with just integers. Is there strings or pointer arguments in this level of assembly, or is this all just ints?
Well, I think C would argue with you that you can write everything with ints just perfectly fine. In fact, you should come and check out the code from my Compute 201 course where that is demonstrated repeatedly. But yes, there are multiple types, but the types are going to be just different kinds of integers. So you can use smaller integers, but you only have I32s to work with. You can store and load 8-bit integers. You can store and load 16-bit integers. You can store and load 32-bit integers and 64-bit integers. You can do math on 32-bit and on 64-bit integers, but they don't have a lot of specific 16-bit and 8-bit integer opcodes. So you can do byte manipulation all you want. There's no character type, there's no string type, and there are 2 floating point types, float 32 and float 64. So this means that when you jam in a string into your WASM, you're really going to write a bunch of bytes into a shared uint8 array, and it's going to read it, and you're going to communicate the size, because we're not going to null terminate the string unless you used C and you're doing LLVM and all that jazz, and you do have to do it. But typically, if you're writing it by hand, you don't have to null terminate anything. You can communicate the sizes. So I think I answered that question. Your types are ints and floats. And if you want smaller stuff, you can use smaller loads and stores. So it's kind of kludgy. I don't really like it. All right, to call a function, you need to use call. It uses a symbol to refer to that function. This is properly type checked that it is a function. I assume the function arguments are called by values such that are copied onto a stack. You do not get access to this call stack, but the arguments are type checked. So this is a nice type checked assembly. That's kind of cool. I'm going to click eval on this one, and it's going to show that it returned 22 because I just jammed 22 into this function. So it ain't that special. All right, so off to the next. So that was pretty cool. We can do that in the browser, right? No. Actually, I had to do a little gong show here where I linked in libwabt to compile WASM in a reveal.js slide deck. It does work, but on your computer, you typically will compile using wat to watb, and that's from the watb project, and it'll compile it for you. But if you want to do it live on the web, you have to use libwatb.js. And that is some mscripted mess that got compiled. It looks really bad. It's like unreadable because it's kind of like WASM. So we've got this little program. What does it look like? Well, if I run wat to WASM on it and I tell it to be verbose, we can see it gives itself a little version number and a little type code. And then it starts a section. And it says it's got a section and how many types it's got. And it's got 2 types because we got 2 functions. And their first function has 1 parameter and it's got 1 result. And our second function has 0 parameters because it's the main function, has 1 result. Okay. And then we go to the section of the function and we can see that it basically is just data that describes the function. And then here is the second function main, and it has an export name and what kind of export it is and what its function index is. So this is just data about the function. This is not operational. This is used for linking and loading. Next is code, and it tells us how many functions we got. We got the first function here, so this is going to be func with arg, and it's got local decal count. It's got get, and it's got the index, and it ends. All right, so it runs get, and that'll be on the stack when it runs, such that when main runs, we can see that it pushes, it says that there's a constant, it puts that onto stack, right? And then it calls it, all right? And then we got the function index and we're done. So it has this left on the stack, this value that we got in here, which will be 22, right? Which is, that's 16 plus 6. So 16 plus 6. So that's that value there. I don't want to write this stuff. This stuff is gross. You never have to look at this stuff. And this is simply a textual representation of the actual binary that it runs. Ain't that fun? Okay, so it looks like that. That's not fun to work with, so we'll stick with WAT and S expressions. But we're stuck with the memory model. WASM has a stack and it hides it from you. This stack contains values you pushed on it and some function call frames that you can't really see. What you can't see is function locations, function code, parameter locations, locals, or the location of locals. So you don't get access to this stuff. You don't get access to your stack like you do in C, or if you wrote assembler by hand. What you can see, though, is you can allocate as many locals as you want, and you can define as many functions as you want. And it will handle function calls for you just peachy keen, and it'll handle calls to imported functions just fine, which is really nice. And you can access some explicitly allocated memory, like a heap. And you can even grow the heap if you want. So it's kind of flexible, but it's very different. Now, I was already asked the question, what data types does it have? It's got 32-bit ints and 64-bit ints. And it's got 32-bit floats and 64-bit floats. One of the problems is if you use 64-bit floats or 64-bit ints, how are you going to get them out? The answer is you usually use a typed array and you write to memory. There's no real good way of getting a 64-bit integer out of WASM other than writing to memory and then reading it from an array buffer. That kind of sucks. All right, I'll just check if there's any questions. All right, looks good. I'm totally willing to answer questions, and please ask them, because it's probably pretty easy to get lost. All right, so we're going to talk about instruction and opcodes. Typically, instructions consume 0 or more values off of the stack, and often they push a value onto the stack. Not all the time, but sometimes. And you can't really access the stack directly, but you can push and pop to it. So first and foremost is how do you make values? Well, .const. And you prefix .const with the data type that you want. So here I've got 64-bit floats, and I'm going to multiply 2.0 times 10 to the minus 9 times 2.1 times 10 to the 10. We're going to evaluate that. Oh, 42, mention that. Here's a 32-bit integer. We're going to multiply our 32-bit float. We're going to do the same calculation. It's kind of close, but that mantissa is not as big, that's for sure. Now we try with the 64-bit integer. Type error, cannot pass I64 to or from JavaScript. Great. Okay, so watch out when you're using 64-bit ints. But it works perfectly fine on 32-bit ints. So, we used hexadecimal to represent the integer. We don't have to, but when we evaluate it, we can see that's multiplying 255 by 65,536. Yeah. All right.
Possible question. This has got a lot of people excited. So Byron Hill in the chat has asked, what's a good project for a practice thing to start using WebAssembly?
I would choose something that has that likes integers, that likes typing, that likes pooled memory. So a hash table, or a special kind of hash table, or maybe like naive Bayes with a hash table. So you're basically storing counts of, say, like n-grams that you saw, like 4 character or 4 byte grams, and you're counting them. So you could use that for spam detection or something like that. That would be if you're doing WASM by hand. Most people, what they're going to be using WASM for is they're going to be taking an existing program that is compiled, like a Rust program or C program, and there's maybe a function in there that they like, and they want to compile it to WASM such that they can call it from JavaScript and use that. I've seen this done a lot with OpenCV or computer audio code, where you're generating like a little synthesizer, and you don't know how to do it in JavaScript, and the code's already there, so why not use it? I think that answers the question. Those are my suggestions. Okay, I'll just check the thing real quick. Mark asked something about SIMD. Later WASMs do support SIMD, but it's not clear it's in the browsers yet. Some of these features will be later. But there is no, I haven't seen anything with the current WASM 1.0 where you can do anything in a vectorized manner. So there's problems with that. Yeah. But if you want to work with 32-bit integers, I really think that WASM is probably for you. It's good stuff. Like if you really want to be right on about 32-bit integers, you don't want any coercions, WASM is a good way to verify or, well, yeah, to verify that you're staying in 32-bit int zone and you're not casting up to a double anytime soon. So that's kind of good. All right. So you got lots of arithmetic in WASM. It does numbers okay. It has things like addition, subtraction, multiplication, division, unsigned division, signed division, unsigned remainder, signed remainder. So with the floating point numbers, add, sub, mul, they're all normal. But with the 32-bit and the 64-bit integers, you will have sometimes unsigned and signed versions. So here I've got a 64-bit addition, and I'm going to add 2.0 times 10 to the 1 times plus 2.2 times 10 to the 1. And oh, look, 42. Imagine that popping up again. Here I've got a 32-bit multiplication, a 7 and a 6, and oh, same number. It's almost like it's hard-coded or something. And then here I've got a division. This is a signed division, and I'm dividing 1024 by 24, and this will be integer division. Can you guess what number it's going to be? Well, I'll just click it. You know what number it's going to be. All right. So that's signed division. We can use unsigned division, and you should only really be using unsigned division if your integers are unsigned values, because treating signed values as unsigned is problematic. Okay.
What about exports? We have another question from Stephen about how would you write to an array buffer? You mentioned that earlier. Do you create the buffer? Is this like a malloc?
I will cover that in detail later.
Excellent. Look forward to that.
Yeah, heavy detail. Let's see if I can push through it. Okay, so we've got to ask questions about array buffers, but first we have to deal with locals. So to make a local variable in a function, you, at the top of the function, not during the function, only at the top, you declare variables local by local, the symbol, and the type. So here I've got local $i32. And because of safety and security, they are going to initialize all your locals, usually to 0 in both cases, positive 0. So local $i32. To access I, we can't just use I directly. I is basically a symbol. So we have to go get local $i, and we can set local $i, and we can set it to a value. Okay, so what are we doing here? We declare the local, and then we go get the local, add it to 42, because that's what all my examples have, add it together, and then return it. So I'm going to eval that, and we can see that it was initialized to 0, because 0 plus 42 is 42. All right, maybe I should use a different number, but just kind of felt that way today. Now, you got a function, and that's cool, but let's not do conditionals just with numeric operations. We have actual conditional operators such as if. And this is where it gets really different, because typically in assembler, you don't have access to an actual if. Typically, you do a comparison, and then you jump if not equal, or you jump if equal, or jump if 0. So they provide a whole if to you. So your if, first you do a comparison or math. So basically, is it 0 or is it not? So what we're doing is we're getting the remainder, the unsigned remainder of x divided by 2. Okay, so this is like x modulus 2. And we're going to do this in a function called even that takes in one parameter. All right. And then on this, we're going to return minus negative 1024, and on this positive 1024. So we're going to jam in 42, and we're going to see what the result is. And we can see that the result of 42 was that this would be a 0. So that meant it took the else case and returned 1024. Okay? Fun stuff. Also, another cool thing is we do have the ability to return at any time, which is pretty powerful given that some scheme languages do not allow such kinds of returns. I have a return value here because I said we'd have a return value. And without declaring a return value on the if statement, it's not going to let me just leave it be. It's not going to do the analysis to figure out there's no way out, which is annoying. But we can make the if statement return a value because we love ternary operators. Who doesn't? And how do we make an if statement return a value? We say that it has a result. We say it has a result and it's got a value. And so using the same thing, I no longer need those extra return statements, and I'll just put in 41 instead of 42, and you'll see that it returns a negative 1024, which meant that it hit this one. So isn't this cool? You actually get an then and an else in assembler. Doesn't really feel like assembler, does it? It feels just kind of atomic and low-level Lisp, you know, kind of weird. All right, let me just check if there's a my face when ternary operator. Good joke. All right. So it also gives us loops, which is nuts, because typically loops are a real pain when you're writing assembler by hand. When you're writing assembler by hand, usually you got to put down a label, and then you got to do the body of your loop, and then you got to do a comparison, and then you got to jump to it. Well, they get around the loop label issue and being able to jump back to that loop label just by giving you a loop opcode. And this is a real opcode. This isn't syntactic sugar. And the loop will basically run everything inside of it. And if you jump at the end of it, you'll jump back to the start of the loop. So let's look at this code right here. I start off with a local. I is set to 0. I set the local to be I plus 1. So we add to I, we add 1, and it'll do that. So will this do an infinite loop? No, it actually just returns 1. Why? Because there's no jump statement here. There's nothing that tells me to go back to the top of the loop. We actually have to do a jump for it. And it's not a jump, it's called branch, which is kind of weird because, I don't know, I don't like the name of it. But if you run branch, you can jump to either a label or you can give it like a 0 or a 1 or a 2. 0 means the current local block. 1 means the enclosing block, 2 means the enclosing block, or the label, which I assume is a type. You jump to that block label. Here we've got a loop and it doesn't have that block. We've got set local from the last example, and now we've got an if statement where we use a comparison operator called i32.eq, which means 32-bit integer equality. And we get two integers, I and 1,000, and we check to see if they're equal. If they're equal, as in we've counted up to 1,000, then we return the value of I. Okay? Otherwise, there's no else on this, so the next thing running is br0, and br0 will hop back to loop, and it'll keep running. So this thing will keep looping. Okay? And then I put get local I down here because I promised that the function would return a value, and the loop didn't necessarily do it, so whatever. And we can see it did it 1,000 times. So it ran through 1,000 times. Pretty, well, it's not super simple, but once you get the idea that the first argument to the if is going to be some kind of comparison or some kind of math that's 0 or not 0, then you're good to go. All right. So sometimes we want to do more than just breaking out of the loop. Sometimes we want to carry on with our function. Sometimes we don't want to return from inside the loop. So if you want to branch, there is a conditional branch called brif. And brif, you can give it a 0 or 1 to tell it what to do. So it's saying branch to 1, that is this block here, if I is equal to 1,042. Okay? And so we run that, and we can see it counted up to 1,042, return that get local, and the return value is right here. So it actually got to the end here. If this is not true, it's just going to fall through, and we're going to run br0, which is just going to keep doing this. But I can only do br1 if there's an actual block here. So if I have a loop here, or this thing called block, which is another structure you can use. Block is... it's just a block of code that you run, and you can even put a label there so you can hop to it. That's how you hop around. And blocks are the only way you're going to get around the lack of go-tos, because you can hop to the block that you want. So here, we've named the blocks. I got an inner and outer, right? Kind of like belly buttons. And what we're doing is we're just looping. This is an infinite loop. So it'll just keep hopping to the top. And then this block is the inner loop, right? And what we'll do is if we hit 1024, we will say we'll branch to the outer. And now because this is a block, right, and not a loop, it's not going to hit this. It's actually going to hop to the end and we're done. So we can hop out by basically jumping to the end of this label, which is really strange. Okay, so you have something like a goto, but it's totally not a goto, and it only works with really local labels, which means that if you're writing a language that likes continuation passing, that likes parallelism, that likes generators, that this WASM stuff is going to give you a headache. And the Go community is really kind of annoyed that WASM is designed this way, because it really slows down Go compilation for WASM. It's quite complicated. All right, so that's branching, and that's as close as goto as you're ever going to get. So we got BR and BR if. There's comparisons. You can do less than, greater than, less than equal to, greater than equal to, equal to 0. And you can jam I32 or F32 in front of them. There's also signed and unsigned versions of each one of these for the integers. So be aware of those. And the comparisons are really they just push a value onto the stack. So here's equal to 0. So we've got main, we got a local, and we check to see if the local is set to 0. If it's set to 0, we return 10,000. We got 10,000. Here's sign greater than. So I32 GTS, we compare them -1 to 1. Is -1 greater than 1? No, it's not. So it's going to return -1. Okay, that's cool. What about this one? I32 greater than unsigned. -1 and 1. So which one is it actually going to return? Is unsigned -1 greater than 1? Well, we'll just evaluate since question and answer is so slow. And it is. Why is unsigned -1 greater than 1? Well, because unsigned -1 is 0 FF, 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 and unsigned 1 is 0, 0, 0, 0, 0, 0, 0, 0, 1, right?
So why was branching designed that way then? If it makes it purposely difficult, is there like a reason why it was designed that way?
The reason is typically for program analysis. So it's important to understand that JavaScript runs fast because of the power of JITting and program analysis. And one kind of program analysis called SSA works really well when you don't have arbitrary gotos. So out of optimization reasons for some kinds of programs and some kinds of analysis, it is great not to have a goto like that. That's about it. So, you know, they kind of are harming performance of certain languages over other languages. But with the ability to analyze code, they probably can figure out ways to analyze the code that had to do hokey things to get around this hokey limitation. That's my impression. All right. Okay, so we'll just kind of breeze through this stuff. I think we're getting pretty close. I was asked, how do we communicate arrays? How do we communicate multiple values to WASM? Well, one neat thing is that we can make a memory object, a WebAssembly memory object, and we can import it. Okay, so we can import it or just have it in WASM. We can allocate pages, and then we can store values into those pages and read them out. So if you wanted to read in 32-bit or 64-bit integers, you'd probably do it through this manner. So this is basically you making a heap and accessing it. The weirdest thing about this is that you'll have address 0 being a legitimate address that you can manipulate, which any C user will immediately shudder and realize that if they are compiling a C program, that they probably shouldn't operate within the first page of WASM memory just so that they can avoid various bugs, or at least the first kilobyte, you know, like. Anyways, so let's take a look here. I've got an import statement saying I'm importing it. So I'm importing env memory, But what I'm really doing, just in case, is I'm saying we have at least one page of memory. So memory now exists. So that means we have one page at least. So we have 0 to address 65535. So 64K. Then what we're going to do is we're going to go 64-bit store, and we're going to store at address 0, which it's like danger zone, but whatever. We're going to store this floating point number. And then I'm going to load that floating point number and return it. Okay, so let's see. Yeah, we got 0.42 out into JavaScript, even into a web page. Amazing. But it was at address 0, which is scary. Makes me uncomfortable. So how do you do arrays? Well, what we'll do is we'll ask in JavaScript WebAssembly to make us some memory. So this, I'm asking for about 65K, I think, or 65 megs, I think. Yeah, 65 megs. And then I'm making an import where env memory is there. Look at that env memory. It was all back here, env memory. And now I'm basically getting my WASM. I'm instantiating it. I'm getting my exports. And then I'm making myself a float64 array. And lo and behold, what do? I pump in buffer. That's from this object here. So that means this has an array buffer that is now shared. So anything that I write to it is now shared between WASM, and, well, at least this WASM module itself, and JavaScript. That's kind of cool. Now, can I put in float60? Can I put in typed array, or can I put in memory buffer as an argument into one of these WASM functions? You can, but it's not going to work. So typically you put in a pointer like 0. Okay. If you don't want to start at memory address 0, you'll put a different number in right there. Okay. So, we're pretty far. All right. So I demoed. I got into WASM because I thought I'd get some good performance out of it, right? I thought that would work. So I made a summation function, and if I click here on the sum, we go over here and we see nothing showing up because this was not made for presentation, I'll tell you that. And so I'll just reload this. And so it took 300 milliseconds to load the sum.wasm, or load sum.wat and compile it and then link it. Then it took my JavaScript WASM over that array buffer. It took it 300 milliseconds to do a summation over all those elements many, many times. So for the one array, it can do the summation in about 30 milliseconds. My basic WASM took 44 milliseconds, and my good WASM took 23 milliseconds. So it can be faster or it cannot be faster. I will go and show you what my summation looks like. So here's my summation. And the first one uses this function called offset. And offset is going to calculate where in the array should we hop to. Okay? And because we're using 64-bit floats, what we have to do is we have to multiply 8 by any index into that array. And we got to add that to the location of the start of the array. So offset just basically produces the array offset. It doesn't actually read the array for us. So here's our first ASM sum. So all it's going to do is going to take a pointer to an array. It's going to take how many elements from that array it should summate, and then it's going to return a summation. So I've got iterator I, I've got output O, I set I to 0 for no good reason, I set O to 0.0 for no real good reason, they're already initialized. And then I have a loop. And loop basically loads at every offset that value. Okay? So it basically keeps loading each consecutive array element, and then it adds it and it stores it in O. And then we iterate. We add 1 to I, and then if we're at N, we quit Otherwise, we loop, 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 loop. Eventually, we return our sum. Okay, so this one uses a function call to calculate an offset, and this sum2 does not. So you see this thing where the load? In this one, I've inlined that with no function call. Okay, so this one's pretty fast, looks like garbage. Let's go look at the results again. In Firefox, by inlining that, I saved quite a bit of time. Significant time. Let's go look at it in Chromium. All right, here we go. I'll rerun this. And we got 26 for straight up JavaScript, 67 for WASM with calls to offset, and 40 milliseconds for WASM to the inline WASM. That's kind of weird. I don't really like that. So let's go look at what my JavaScript one was. So the cool thing is I can communicate to WASM with JavaScript by writing to this array. Here's my JavaScript sum. So we just start with 0, we go through, and we add. Pretty easy. And then how many repetitions do we use? We use a lot. I'm iterating over 10 million times, and we do that 10 times. So the arrays are quite large, and we do it 10 times. All right, so it can be faster. It might not be faster, and it depends on the browser. And frankly, I think my Chromium got slower because when I ran it last week, Chromium was faster. So I don't know. All right, let me just check for questions on that one. Do. All right, question. Do you think a compiler like Rust would inline the function for you? I sure hope so. Function inlining is probably the biggest gain you get from WASM. So probably that's really what the compiler gives you, is the ability to make that code less annoying. The fact that you're writing your own WASM function, you're directly using call, indicates that you're going to be relying on that thing to be faster. And it might not be faster for you because it's going to have safety checks in there. So that's a good question. Let me see. Okay, so you declare buffers, then you call WASM, then it writes to the buffer. Yeah, so you can declare your buffers, you can call the WASM, you can write to the buffer, you can also write to the buffer before you call WASM, and you can even read from the buffer after you call WASM. And then there's new extensions that allow you to have a shared buffer between both of them. All right, so let's see. Performance, it depends. My Firefox was pretty good. My Chrome was really great for JavaScript, not so great for WASM. It's kind of, but none of these are really horrendous. None of these are like, I don't know, over 4 times slower or 4 times faster. So that's fine. That's fine. So I was thinking, that was just summation. That stuff's easy. That's like SIMD garbage, easy peasy. What about something that's actually computationally intensive, like a recursive function like the Mandelbrot? So the Mandelbrot function is a function that you call many, many times, and when you find that it's not converging anymore, you quit. Or something along those lines. So you've seen Mandelbrots before. They look really pretty. These are 4 of them that just drew because I programmed them in JavaScript and WASM. These Mandelbrots took 81 milliseconds in pure JavaScript going pixel by pixel, or 181 milliseconds, 170 milliseconds calling assembler WASM, and then putting it all into JavaScript and not leaving and not like iterating over every element in the buffer, not calling a function to actually calculate the function. It took 170 milliseconds, and the WASM Mandelbuff took that. On Chrome, let's just take a look at Chrome. Bada bing. Chrome is all over the place. So its JavaScript Mandelbuffer is great. It's 178, and its WASM one is awful. It's 275, but it's still not on the order of 2 or 3. So I'm not willing to really bag on it too bad, and it can always improve. Now, I'll show you what the code looks like. I hope it makes sense. We're going to start with the We're going to start with the JavaScript, to be honest. So first off is the JS mandel function. What this function does is it does the Mandelbrot function, which is basically Zn equals Zn minus 1 squared plus C. C is your original point. It's your XY coordinate in the complex plane. And then Z0 started at 0. Complex numbers are basically tuples, one in the real domain, one in the imaginary domain. So it's really just like 2D positions. Anyways, what happens is we keep repeating this calculation over and over and over again. And if we exit a certain space or we hit max iterations, we just quit. Okay? So the less iterations you have, the more likely that you're not within the Mandelbrot. If you're spending a lot of iterations, you are within the Mandelbrot. Okay? And so that's how we do basically every single pixel of this pretty Mandelbrot picture. Okay, I'll make it big. All right? So let's look at how we do that in assembler. So first off, we write the mandel function, right? And it's got a lot of locals. Okay, we've got our iterator, we've got our complex numbers, zx, zy, and the squares of those numbers. And then we do all the annoying math. So we set zx, we set zy, we set zx. So we do floating point addition, multiplication, and then we square them. And even squaring looks awkward. It's the multiplication of two get locals. And then if it's, we branch if it's equal to max iteration, or we branch if it escapes the Mandelbrot sphere itself. Okay? Then we also do the drawing each pixel in assembler. So we have a while loop. So this is for per row. And then we have a column loop, so for x value. And we calculate what the location is, which is just this calculation, something like that. And then we do a call to our Mandelbrot right here. And you can see this is why it's really annoying. Now I want to show you this stuff. I was asked, can I use other data types? Yeah, you can. So here we're doing 8-bit storing. So I'm storing 8 bits at a time. I'm storing red channel, green channel, blue channel, and alpha channel. All right. So it stores all that, and we get the Mandelbrot. What does that ugly code look like in JavaScript? Well, we'll look at, where is it? Draw Mandel buffer. We get our canvas. We get our image data. We do it as a array buffer. And in this case, we're going to be using, a 8-bit integer buffer. And then, where is it? Here it is. This is our JavaScript that writes to the buffer. So we're really just writing to pooled memory. We calculate the Mandel result. We clamp it down between 0 and 255. We set our RGB all the same. And then we set our thing. So you can see that this is pretty small. Writing assembler kind of sucks compared to this. And this is fast too. So then when we run it, what we get is we get some pretty Mandelbrots, but we can see that there's not a huge difference in performance between both implementations on both browsers. In fact, JavaScript Mandelbuff typically dominates. So JavaScript's really beating the web assembler out right now. So that's kind of interesting. So where does performance in JavaScript come out of? What do you usually get out of it? Well, it can improve in the future, but I think most of it comes from the productivity of you using that old Fortran program, you compiling it down the WASM and being able to call it client side on the web. You know, maybe you got some computer vision stuff. You compile it down and you know it's going to be no better, no worse than JavaScript. So that's cool. And you get those advanced functions that you couldn't find in NPM. So there's some real value there. But really, I think where WASM will shine is that the binaries are pretty compact. So you'll likely have better, faster load times compared to straight out JavaScript. So if your metric is essentially, can I do the computation, show it to the user immediately, and the code size is quite large in both cases, WASM might win out. So that's where you might actually get your performance increase. What should you look into for WASM? Well, you should consider using LLVM to compile C to WASM and script them. You can also use Rust and Go to generate WASM for you. They have WASM backends. Conclusion, should you use WASM directly like I did? Probably not. Is WASM useful? Yeah. If you want to do integer stuff in JavaScript safely, probably WASM's the right way to do it. Yeah, if you want to compile other languages such that you can use them in the browser. Does it perform well? Yeah. Not super awesome. Not like you're thinking, oh, I'm handwriting assembler, it's going to be way better. Not necessarily. Not necessarily. It's fine. Is it worth the effort? Most cases, probably not. But I suspect the big gain is from using a real compiler. Do people use WASM like I've been demonstrating? No. I just wanted to know what WASM was. Like, what was it actually compiling down to? What was the virtual machine? Most people are going to use a high-level language or almost high-level language and generate WASM from that and use that. Okay. And there's a lot of good resources out there. So if you want to do this but more, Justin Lim has WebAssembly MVP tutorial. There's WebAssembly by example. These people also use like Rust and other things. The MDN spec is okay. The WAP project is what you're going to really need. This Colin Eberhard, he does a ton of fun WebAssembly by hand, and he explores more modern features of WebAssembly. And sometimes, you just want to see a list of opcodes. This list of opcodes is peachy keen and super cool. I really like it. It even tells you the opcode value, and you can see the opcodes are really small. They're like 1 byte, and it gives you what happens to the stack. Like this one says, 2 32-bit floats produce 1 32-bit float on the stack. Pretty handy, very terse and concise, and you get to see everything that you've got access to. All right. So I think I'm going to come back to the questions. All right. I think I'll switch to something that's less confusing. We will go to space. All right. Question. What does runtime error look like if you, I gotta move this over, if you call it JavaScript with a string? You get an error from the WebAssembly object, and it'll show up as an actual full-out error. So it'll show in your console. Yeah. It's kind of annoying. Oh, the other thing I do recommend is at the end of my slides, the last page is a live demo where you can try WASM out for yourself. Or it did work. Don't know why it's not working now. All right, whatever. But you can try it out for yourself, and if that doesn't work, you can go use this demo that someone else got that shows you everything. Not sure why the slides don't work. Anyways, I'm going to come back and answer questions because it's getting late. All right. I think it'd be cool to write business logic, state management, and Rust, and then you could share it. Yeah, Rust would be a great way to do it, and you could maintain the binary format really easily, and you wouldn't have to write a decoder on multiple ends. Or you could use something like one of Google's things, like the I forget their efficient binary protocol, protobuf or something. You could use the protobuf bindings on both sides without any problems and without having the write for multiple languages. So there's real value there. All right. Examples of WASM used in production. A lot of games. Games were doing stuff like that. The C-Sound community uses WASM heavily. They also use this other technology called PNACL, but PNACL is going to go away. And so they're compiling to WebAssembly. So there's a lot of people who do like live audio coding on the web for performance reasons. Like, like performing to an audience reasons. So they do like algo raves and live coding. And that's where there's a lot of old audio code, and a lot of that is shown up there. So any kind of signal processing on the web oftentimes will have this stuff. I know that my colleague Nathan uses WASM and Inscriptum. So he does Inscriptum to WASM for his C++ code. And he's even got like a kind of cross-platform GUI where he can compile a bunch of his heuristic search examples, and it'll work, you know, off the console with a graphical GUI, and it'll also work in the browser. So it's pretty cool. All right. Yeah, so OpenCV for WASM, that's really what you would do. Mark has a question, or all right, I'll do Mark's question. Do you think WASM will ever work with garbage collector? It kind of does. So it handles its own stack. So in that sense, it is kind of working there, but I don't think you're going to get access to the JavaScript objects anytime soon. What people will do when they want to interact with JavaScript and the JavaScript GC with WASM is they'll make a malloc routine on their own, and that will be imported from JavaScript such that you will allocate in JavaScript and have some weird WASM access to it. So if you want to send in like a dictionary or an object into WASM, typically you're going to make an import object for JavaScript. So if you really need to walk objects in WASM, you're going to make a bunch of little handlers in JavaScript that will be imported such that you can walk them. And that will probably be very slow and annoying, but sometimes you just need that data right now, so just do it. All right, there's another question.
Cool. I think that's our last question. So thank you, Abram, for a fantastic talk. There was tons of questions during it. I know you've ignited a fire in some of the people here for checking out WebAssembly and being thoroughly impractical on the web, which I think we can take a little bit of inspiration from in our personal lives as well, just to be a little bit more impractical.
Thanks.
So thank you, everybody, for joining us. We will have some slides appearing here in just a second. Boom, there we go. And we will give it the 2-second pause so that we can properly isolate the audio. Excellent. So we'll have Mark joining me either here or here up there. And he's just going to speak briefly about the Dev Edmonton Society. So first of all, hello, Mark.
Hello, everyone. I'll be super quick here. So for those of you who don't know, I'm Mark Bennett. I am the president of the Dev Edmonton Society. We help meetups like this in the city, and we're trying to get more people involved in the organizing side. So we are trying to share more when we have meetings and stuff like that. I just wanted to let everyone know that we have one coming up here on June 28th. 10 a.m. It's a Sunday. It's early. We will do basically what we're doing here, and we're going to be talking about a couple interesting things. We have our board elections coming up in July, so if you want to make a difference in Edmonton's developer community and in the meetups, it's a great way to get involved if you have experience running meetups, and if you come especially from a diverse background, we really want to get people out there. We won't be having the election in June here, but it is coming up, so we'll be talking about it a lot. Other stuff too, we're going to be talking about kind of what meetups look like during this kind of pandemic world that we're living in. So we want to know how meetups can kind of adapt for everyone. So if you have thoughts on that too, you can hop into our Slack. We're in a channel called Dev Edmonton Society there. And you're welcome to bring up topics that you want to talk about too. Anyway, I'll be in the chat after this as well. So if you have questions for me or want to know more, find us on our Slack or find me there. Thanks.
Awesome. Thanks, Mark. As always, these meetups don't happen without our sponsors, which when we are all in person, pay for things like food for us. So if you haven't been out to an in-person meetup, once we're all allowed to be within 2 meters of each other, come out for some food and some fun talks, as well as some drinks afterwards. So I always randomize these because I feel a little bit awkward because the company that I work for sponsors us. So first up is Iron Sights. Rather than in-person meetups, we usually have people stand up and explain kind of their company because they usually are in attendance. So Iron Sights does, I believe they do oil field tooling, and so they have some software that some oil field companies are using. I'm not familiar with what their stack is, but I know that they're based out of the startup space currently. Next up is PunchCard, which is the company that I work for. We do software consulting in the mobile and web space, as well as building websites and kind of helping people manage document portals. And then the last is Jobber, which they do have a large product, which is software that runs sort of odd jobs, so allowing people who maybe don't necessarily have a full business to do things like home maintenance and to like bill and to do all of that stuff. It's really cool. So we are also sponsored by Startup Edmonton. You aren't seeing these nice, beautiful bricks that are right here right now, but they have a fantastic space where we are typically. And once we're back there, you will get all the benefits of the Startup Edmonton space, including a bar in the basement, 2 bars in the basement, as well as Roast's Auto, if that's your thing, which it definitely is mine. Lastly, there is always a need for sponsors. There are always costs to put these things on to keep all this great content coming. So if you were looking at sponsoring Exchange.js specifically, you can go to sponsors@exchange.js.com and get in touch. Our next meetup will be on July 2nd, 2020, which again, no need for birthday presents, it's fine. And it will likely be online as well. We're going to keep being safe, trying to make sure that we are remaining social distance as long as that is kind of the recommendation from Alberta and from Canadian provincial health authorities. That being said, we will have a virtual social. I believe Mark is going to be posting the link on YouTube. So if you want to come and hang out, ask questions, like I said, if you want to email me, if this is your first time here, I'm happy to answer any questions. I will also be in the Zoom call afterwards. I just have to go get some food first. So thank you everyone for coming out. Thank you again to our 2 amazing presenters. Congratulations, Richard, on your very first Dev Edmonton presentation. I hope it isn't your last, and thank you again, Abram. And a huge round of applause to Mark for running everything behind the streams and just making sure that it looks like I know what I'm doing, when in fact, he's running all of the tech. So thank you all. I hope we have a fantastic night. If I see you in the Zoom call, fantastic. If I don't, I will see you all in July. Bye.